Alright, so far we've learned how to find our coordinates of intersections with the help of the Cartesian coordinate system. And then we've entered those coordinates in the GWizard editor, and we make sure that we connect them in a clockwise motion, representing a tool path where we're climb cutting the outside of a part. Alright, so in this example here we have a 4x4 square, and you can see a red outline, and that is the extra stock that I would have on my part, which we're looking to cut away. So what we've learned so far, and I'm going to make a representation of our toolpath, is we find our coordinate of, in this case, the far left corner. We come down and then we move to the next corner, and as we go around the part, we have now completely machined the square of the part, but notice the representation of the toolpath is actually inside of the green 4x4 shape. So with this being a 1/2 inch end mill, we've taken off a 1/4 inch too much per side. So this is actually a 3.5 by 3.5 when we're done cutting. So we learned how to find coordinates, but now we need to learn how to create tool paths where the tool is actually offset half the diameter of that tool to make sure we're not undercutting our part. So let's transition from finding coordinates to creating tool paths. So the first thing we need to learn is whenever we approach a part with our tool that we make sure that we don't plunge into the material as we come down in our Z value. Okay, so in the previous example I came right down on this intersection where you can imagine I'm plunging right down into that material before I start my tool path. So we need to get off of the part, which is called a lead-in move, and let me show you what I mean by that. So now the tool is coming down away from the part. So if we look at the coordinate down here in the lower left hand corner, my X value for this position is X minus 2.5. So I've actually added an additional 1/2 inch on the center line of that tool. And then also notice that the bottom of my tool is now even with the outside of my part. So this being a 1/2 inch tool, I've had to offset it a 1/4 inch, 250 thousandths. So this line sits at 2 inches, right? And then half the diameter of that tool means the tool is sitting at Y 2 inches 250. Okay, so that is our first point. We're sitting at our approach point, and from there we go to a straight line to this corner here. Now notice where that ends up. So not only did I travel at a 1/4 inch above or away from the part geometry, we also had to add a 1/4 inch to the end point of this tool path to make sure that our tool is lined up with the next piece of geometry, which meant we had to go a 1/4 of an inch further than the 2 inch geometry. Notice that right here on the Cartesian coordinate system, that's 2 inch. The tool is a 1/2 inch. So right now we're sitting at X2. If you look at the far lower left corner, X 2 inches 250, and we're sitting at Y 2 inches 250. So half the tool in addition to the actual coordinate of that intersection. Alright, so we move on to the next one. So we're sitting at X 2 inches 250, so 250 thousandths beyond our geometry, and we're in line for the next tool path. So it's the edge of the tool in line with our geometry, meaning the center line of the tool, and remember that is the code that the machine is looking for. The center line of the tool is now a 1/4 inch beyond our 2 inch or minus 2 inch geometry. Okay, so we're sitting at Y minus 2 inches 250. So again, we move on to the next. Now, this is our 2 inch line on the left side of the part. Our tool is now lined up to make the next tool path. So it's sitting at X minus 2 inches 250, Y minus 2 inches 250. And then we complete the move And it's not necessary to actually go 250 beyond the part. I could have stopped at 100 thou, but just for simplicity, we will just keep adding that additional 1/4 inch. So that is now creating a toolpath that actually leaves our 4 inches intact, but we have removed the excess stock that's sitting on the outside of the part. So let's compare the code of our two operations, where we do line center based on the geometry of the part, and then also line center based on the toolpath the way it needs to be. Alright, so I have posted out the program, and you can see it starts with the percent sign that is used for communicating between your software and the machine for uploading. Then program number 1 with the description of the program. We're going to use tool number 1 with a 1/2 inch end mill. And if you have that information in the top of the program, then it helps you to know how much the tool is going to need to be offset from your geometry to be able to do your toolpath. Alright, so line number 10 is where we start our first toolpath, which is based on the coordinates of the part shape. So we're sitting at x minus 2, y2. So if we single block through that, I'm going to approach in Z, so that is your spindle coming down. We're going to G1, Z minus 0.5, so we're feeding a 1/2 inch below the top of the part. Then we do an X 2 inches, so that is the first toolpath to the opposite side of the part. Then the next line, we're moving to Y minus 2 inches. We complete that move, so that would all be line center, but as we discussed before, this will undersize the part by a 1/4 inch per side, so a 1/2 inch on the overall. So in the next segment, we're going to actually use toolpath the way it's supposed to look, and so our approach point is x minus 2.5. So you can see our dot right here. That is our lead-in move. And then we come down in Z. Our first point is x minus 2 inches 250. Next point is x 2 inches 250, y 2 inches 250. And if I bring this up, let's see here. Yeah, here we can actually see the x and y coordinates. Then we know that our tool is actually on the outside of the part. Okay, so here we go. We'll go to the bottom side of the part. So again, you look at your coordinates. The first coordinate is the x value. So we're sitting at x 2 inches 250, y minus 2 inches 250. And we keep cutting at z minus 0.5. Next move, we're sitting at x minus 2 250, y minus 2 250, and back on around, just a little bit past the part, x minus 2 250, y 2 inches 250. So you can see that is the difference between what we learned in the first week, and now we're offsetting our tool, creating actual tool paths that you will see in most code that has been generated by CAD software, because it automatically offsets the tool path by half the diameter of the tool. So that's what I really want you to learn in this session. Alright, so in this segment I'm going to talk about having moved the origin to the far left corner instead of in the center of the previous example. You can see the crosshair that is located on the actual intersection of the finished part. Now always notice that the excess of the material, alright, is what we're going to cut away. So once we cut away that excess, we need to be able to find the origin by touching off on the top leg and the left leg, okay, to find the origin of that part again. So always make sure that you put the origin on the finished part, not on the intersection of the excess material. Okay, I hope that makes sense. Alright, so having moved the origin to this corner, let's go ahead and step through the toolpath and see what the xy coordinates are at this point. So we're sitting at x minus 0.5. So now that x minus 0.5 can be larger, can be smaller. It all depends on how much material you have sitting on the outside of your part. So always make sure that that is enough of a lead-in. Okay, so the bottom of our end mill is in line with our first piece of geometry. And so since again this is a 1/2 inch end mill, our y center line is sitting at y.250. So the next point will be the far right corner. And so the part overall length is 4 inches. So in this case we need to go 4 inches plus half the diameter tool. So you can see in the lower left hand corner, if you can read it, we are now sitting at x 4 inches 250, y 250. Okay, so the edge of our tool is now in line to make a straight line move down, okay, to the next intersection point. So let's complete that. So again, we'll go past the part. Always make sure that you are ready to be lined up with the next piece of geometry. So that means we are sitting at x 4 inches 250, y minus 4 inches 250. We'll complete that move. So this line is actually sitting at x0. So we need to be to the left or the minus side 250 thousandths past that piece of geometry, so that the edge of our tool is lined up with the next line or last line here. So we're sitting at x minus 0.250, y minus 4.250, and then we complete that move. And we're sitting at x minus 250, y 250. And we moved a 1/4 inch past the part, but if I zoom in, you can see this is the cutting, right here, the cutting edge of the tool, and it has actually moved 250 thousandths past the part. Okay, had you moved 100,000 past the part, that would have been sufficient, and that's where you would retract your z-axis. But just to keep things simple, I kept it at 250 thousandths. So this is just a simple illustration of how we offset our tool based on the diameter of the tool. And it's always important, of course, where we place our origin. That will determine the plus and minus values of our x and y coordinates.